All right, we're almost done with this. We don't have a ton to go, so this will be a pretty short lecture, and then I think we're gonna pivot to filling out a post-lecture survey and then moving on to just talking about each other's projects and implementations. And we can do some of that. We can work on a Project Euler problem. We'll have a little bit of downtime. I figured we would have about, at most, half of the class here on a Friday before a 3-day weekend, so I didn't want to do too much. But we were talking about the observer pattern. What was the observer pattern? Someone give me a recap.
You have like you have an interface and then you have like a subscriber thing and it'll update. So like if you have like classes that are linked to the subscriber and every time there's an update, it'll get notification and then it'll send it to the classes to update the stuff basically. Yeah, so we have some kind of subscription service. We have the subscriber and we have the subscribee. So we have the subject and the observer, as we're going to start calling it. So the subject is going to be publishing things and the observer is going to be waiting for said publish. So how we actually connect to this is part of this UML. So this is kind of the weather station's UML. We have all of our different displays. Each of the displays need to be updated every time that something is published by the weather data, the concrete subject. So as they do this, we have all of these updates and displays. So when the weather data publishes something, all of these updates are going to get called for each of the different displays, since they're part of the subscriber, they're the part of the observer list inside of the subject. So it's going to go through every single one of those registered observers and it's going to say, hey, I have an update for you. I'm going to call your update function. Since I know that through this interface, we don't care what kind of observer they are, we just know they have an update. So we can just call their update and whatever class they happen to be, it runs that update for that logic that we've coded for that particular display. So it goes through and just says, you update, you update, you update, and sends the associated information to them. How that makes its way into the display is part of the update and display logic inside of each of these different displays. So the actual code for this, if we go back and now look at the actual code side of it, we have I'm going to zoom in on this, we have a subject interface and an observer interface that just have the associated method declarations because they're interfaces, we don't have any implementation. And we have a display element that says every display element is going to have a display. So you can be both an observer and a display. We get to implement multiple interfaces. So this is why we want to code them as interfaces and not abstract classes, because we can only extend a single abstract class. So what do the display elements look like? Let's take a crack at that real quick. We have a little bit of time today. So think about what interfaces does it implement? How do you make the constructor? What do we need to do on construction? How do we implement the update and display methods for each of the different display implementations? So see if you can think of the associated logic of how you would actually implement the logic in the UML. You should.
What thoughts do we have on this? What interfaces do the display elements implement? They implement both the observer and the display element interfaces. So we have 4 different displays. Each one of the displays implements 2 different interfaces. The observer and the display element. Let's take a look at an example to talk about the constructor and the update and the display. So we first need to set up the ability to make one of these. So we need to have the actual weather data. So we're gonna make one of the displays. We pass the display the weather data object to be able to connect them together. We need to know where to pull information from. We do the same thing for each of the different displays. So now that we've instantiated each of these displays, we can now set the associated measurements, simulating that the weather data is updating a few different times. So when we do this, we should do something with the displays. So what do the displays look like? Here's an example of one of the displays. Implements both the observer and the display element. When we construct this, we need to take in the associated weather data that we're going to be looking at. We then need to do that, and we need to register it as an observer in that weather data. So we're gonna register the weather data.register observer that says this current conditions display wants to be updated when new weather data is published. When that happens, update is going to take the 3 elements, the temperature, the humidity, and the pressure of the new values of the update. When this happens, we want to set the values of those fields. We want to set the temperature, set the humidity, set the pressure, and then display. I guess we don't have a pressure in this conditions display. So when we pass in all 3 of those things, we only set the temperature and the humidity before we display. So that's all it is. This update gets called automatically from the subscriber interface because it's registered as an observer. The update gets called whenever there is new data. So from the observer's perspective, we don't care to check for the update. It's like waking up in the morning and finding a newspaper on your doorstep. How did that get there? You don't need to know. You paid for it. It's there. It shows up there in the mornings. Probably all there is to the implementation. It's very similar to a newspaper subscription. So thinking about what information does the publisher need to know, what information does the subscriber need to know, that's very similar to the construction of the actual code of this object. So we register it as an observer and stuff just happens. The update is called automatically. Questions on this code? that's everything that I'm planning to go over with regards to the observer pattern. Like I said, it was gonna be pretty quick. But that's the observer pattern. We have the associated UML, we have some examples of what the code would look like. And it adheres to that pattern. Does anyone have any questions about the implementation? Anything generic about the observer pattern? All right, I have revealed a new survey on Canvas that I would appreciate if all of you went and took about how the observer lecture went for you. This one is shorter, it's only 7 questions. Was anyone not here yesterday? So for all of you, there is a pre-survey that is up. That is something that you should go take instead. So you were not here for most of this lecture, so the questions that we ask you about this will not be as relevant. So please go take the pre-survey instead of the post-lecture 12 survey. And that way, if you were around for lecture 13 or lecture 14, you can give your feedback on either of those lectures as well. I'm planning to switch up a little bit how I do some of the lectures for a couple of the lecture types. So you go to Canvas, quizzes, and under quizzes, there are a couple of surveys revealed depending on whether you were here yesterday. If you were here yesterday, then take the post-lecture 12 survey. If you were not here yesterday, take the pre-survey. And then if you were not here yesterday, my recommendation is to watch the lecture videos back for the last class period and this one, and then please fill out the post-lecture 12 survey over the long weekend. I would really appreciate the data. We really need a sample size. When we have as few students showing up as we do, we need that sample size to be able to come to any kind of reasonable conclusion. As far as the recording is concerned, this is all of the new material I plan to cover today. I'm going to stop recording.